So we're going to do problem 10.1.1. 20 different statistic students are randomly selected. For each of them, their body temperature is measured in degrees Celsius, and their head temperature in centimeters is measured. So for this sample of paired data, what does R represent? What does rho represent? Well, the rho, the Greek letters always represent a parameter, and the Roman letters, like R, always represent a statistic. Well, 99% of the time. There are a couple of differences, but that's a rho. That looks like a P, but it's a Greek lowercase r. So it's the parameter, and you're going to estimate it with R from the sample. So the correct answer is obviously A. I read it kind of fast, but I think that's, but see, what's wrong with A? Why wasn't it correct? R is a statistic that represents the proportion of variation in head circumference that can be explained by the variation in body temperature. And rho is a parameter that represents the value of the linear core that would be computed by using all of the paired data. Let's see, B. R is a statistic that represents the value of the linear correlation computed by the paired sample data, and rho is a parameter that represents the value that would be computed. Yeah, I guess it's B. Let's see if that's right. Okay. And then what they're trying to drive here in part B is, without doing any research or calculations, because we don't have any data, do you expect there to be any relationship between body temperature and head size? And given all the people in the world, I don't care what kind of sample you pick, unless if you pick a random sample, there's not going to be any relationship. So there is no correlation. So it's likely to be 0, which means a straight line, a horizontal line. There is no correlation. Choose the best answer below for, does R change if the body temperatures are converted to Fahrenheit? Well, the dots change, the scatter plot changes, but still there's not going to be any correlation. So that would be A. It doesn't matter what scale you use, because temperature is just an arbitrary scale anyway. Oop, maybe I read it wrong. Oh, it's this change, does not change. I'm sorry, I read it wrong. So I got 2 chances, just like everybody else. All right, so that's question 10.1.1. Let me go ahead and shut the video down and pass it on.